Welcome back to Sec Plus, as presented by the 336 Training Squadron here at Keesler Air Force Base. So today we'll be talking about Industrial Control Systems, abbreviated ICS, Supervisory Control and Data Acquisition Systems, also known as SCADA systems. And we'll be talking about the Stuxnet worm. So industrial control systems refer to all the different types of control systems, and each of these control systems consist of a set of devices used to monitor and control industrial equipment or infrastructures and to operate or automate industrial processes. ICS are commonly used in factories, water plants, power plants, dams, power grids, gas, and water pipelines to monitor the industry and to automate the processes. Can you think of any others? So with ICS, centralized control is important, so it is useful to link multiple of these control systems into networks. And in the early stages, these ICS networks use specialized network technologies such as Ethernet, but many have since adapted the TCP and IP networking protocols. And back then, ICS were mainly used to monitor and control industrial equipment, but now are commonly used to control day-to-day appliances such as HVAC systems. So if you go into a server room, there's a chance that there's an ICS equipment operating there. The two most common types of ICS architecture are number one, supervisory control and data acquisition systems, SCADA systems, and number two, distributed control system, DCS. So there are many differences between SCADA and DCS. With SCADA systems, you have control at the more supervisory level rather than full control of the different industries. This is mainly for large-scale distribution systems, and it is focused on information gathering and monitoring. So how this works is you have field devices which are placed in strategically placed in field sites. And these field devices control local operations, such as opening or closing of valves and breakers, collecting data from the sensor systems, and monitoring the local environment for alarm conditions. And then the SCADA system uses a centralized control system for long-distance monitoring and control of these field sites. With DCS, you have a little bit more extended control of the production systems, and then a little bit less supervisory control, so you're more hands-on rather than supervising. And it's focused on real-time monitoring, and you have control of the process states. So how this works is you have a centralized supervisory control loop to manage multiple controllers or devices that are part of the production process. And because you have this centralized control loop, industries are able to quickly access their production data. And because you have multiple controllers or devices, you have good fault tolerance, because if one of these devices fail, then the other controllers and devices can quickly take over, and it won't affect the production process that much. But because ICS are a specialized network and have been traditionally designed without security in mind, there are lots of vulnerabilities to it. And when you are working with expensive and industrial critical equipment, security is definitely important. So in 2007, there was the Stuxnet worm attack. And the Stuxnet worm was a computer worm that targeted SCADA systems of large infrastructures. It brought down a nuclear facility in Natanz, Iran. And it was spread mainly through traditional networks and USB media. And this really brought to light the vulnerabilities of ICS to cyber terrorism and all the consequences that involved. Because these ICS systems were specialized, the creators mainly focused on cost, speed, and efficiency, and really didn't keep security in mind. And as Sec Plus students, this is really important in terms of security. So today I talked about industrial control systems, ICS, and then I talked about the supervisory control and acquisition SCADA systems. I also talked about DCS. And then finally I talked about the Stuxnet worm. That concludes my briefing. Thank you for tuning in, and have a great day.